So we can start second module, that is electromagnetic waves. So let's see how we can derive the wave equation. From Maxwell's third equation, you know that curl E is equal to minus dou B by dou T. We know that, we learned it in last module. So curl E is equal to minus dou B by dou T, and B is magnetic flux density, and this magnetic flux density B is equal to mu H. Okay, mu is permeability and H is field intensity. So on applying B is equal to mu H, you can write this as minus mu dou H by dou T. You know that B and H are vectors and mu is a scalar quantity. So curl E is written as minus mu dou H by dou T. We are taking curl on both sides, you get del cross E is equal to minus mu into dou by dou T of curl H, because here H is the only vector. So you are applying curl with H. So you write like this. So first is the third Maxwell's equation. You wrote it like this. Then you take curl on both sides. You get this equation. Okay. Next step is, mathematically you can write del cross E as del of del dot E minus del square E. So for this derivation we assume a charge free region, and because of that del dot D we know that it is rho V, but as there is no charge, according to our assumption del dot D will be 0. So D is epsilon E. So del dot E will also be equal to 0. So why we take del dot E as 0? Because we assume a charge free region. So del dot E will be 0. So on applying this value here, you can write del cross E as minus del square E. That is like this. So now we are combining the earlier equation and this equation. Earlier you got it as minus mu dou by dou T of curl H, and you are substituting this here. So you can write minus del square E is equal to minus mu dou by dou T of curl H. This we got in last slide. Okay. So now you are equating these two, and curl H you are substituting fourth Maxwell's equation. Fourth Maxwell's equation is curl H is equal to J plus epsilon dou E by dou T. If you are writing dou, you can write like this, or you can write epsilon dou E by dou T, where D is equal to epsilon E, where E is electric field intensity and D is electric flux density. Again, we assume a charge free region and a current free region. Okay, because of that J is taken as 0. So you can take J as 0 and you can write minus mu dou by dou T of dou D by dou T. That is minus mu dou square D by dou T square. Again, substituting D as epsilon E, you can take epsilon outside and you will get minus mu epsilon dou by dou T of dou E by dou T. Okay, so you get the equation like this. Del square E is equal to mu epsilon dou square E by dou T square. If electric field is in, so this is the main equation, you have to remember this. Del square E is equal to mu epsilon into dou square E by dou T square. Okay. If electric field is in x direction, if we are assuming it to be in x direction, then what will happen? It will not be having any y or z components. So E, this is the time, this is derivative with respect to t, and del square means derivative with respect to x, y and z. So del square E can be rewritten as only derivative with respect to x, because y and z the value will be 0. So del square can be reduced to dou square E by dou x square. Okay. So you can write like this, del square Ex, that is mu epsilon dou square Ex by dou T square. Okay, you can write like this. So here we can go through the basics of waves. Okay, wave, it transports energy or information. Okay, it is a function of space and time. Space, by space we mean like the coordinate systems like x, y, z coordinate, how it varies with respect to x, with respect to y, with respect to z. That is function of space, and it's also a function of time. And wave equation, this is a general form, dou square E by dou t square minus u square dou square E by dou z square is equal to 0. And if you try to solve the second order differential equation, you will get like this. This is the solution. And you don't have to solve this, you just understand the equation. Okay. So, from this you can find that there is a positive travelling wave E plus given by f of z minus ut, and a negative travelling wave given by g of z plus ut. So from this you should understand that if it is in this form, z minus ut form, then it is moving in positive direction. If plus, it is moving in negative direction. That is one thing which you have to know. And second thing is that here z, that means the wave is propagating in z direction. Okay. Now let's go through all this. U is given by the velocity of the wave. Velocity of the wave, it is given by product of frequency and wavelength of the wave. F lambda, frequency into wavelength, is equal to velocity. That is one equation you should know. Next is angular frequency. Omega is equal to 2 pi into f, where f is frequency of the wave. This is another equation. Next is beta, phase constant. Beta is equal to omega by u, where omega is angular frequency and u is the velocity of the wave. Okay. Next is propagation. This is phase constant beta. That is also equal to 2 pi by lambda, where lambda is equal to wavelength of the wave. Okay. So all these are the basic equations which you should know. Velocity is given by product of frequency and wavelength. Then phase constant beta is equal to 2 pi by lambda. Then this equation, this is also an important equation. Beta is equal to omega by u, or velocity u is equal to omega by beta. Next equation, t. Time and frequency are related like this. T is equal to 1 by f. As we know that f is omega by 2 pi, you can write as 2 pi by omega. So all these are the basic equations which you should know. Let's go through one problem. Here it is given that the electric field is given. Vector E is equal to 50 cos 10 raised to 8t plus beta x. So the common equation format for electric field is, it is if electric field is given by E is equal to E naught cos omega t plus beta x into unit vector ay. Okay, this is the format given. So here this part here in this problem, it is 50, E naught is equal to 50. That's the maximum amplitude of electric field, and the electric field direction is given by ay. Okay, so vector E is in which direction? Y. So electric field is in y direction. It is in y direction. Then next this part, beta x means it is positive, it is moving in x direction, and negative or positive depends on this sign. So plus means it is a negative travelling wave and it is in x direction. So it will be minus ax. So propagation is in negative x direction. Why? Because here beta x is given, so because of that x direction, and if it is positive direction you will write omega t minus beta x. Here as it is plus sign, we write it as negative x direction. So first question is find the direction of propagation. Direction of propagation is negative z, negative x direction. Okay, so propagation is normally given by this vector, vector k, propagation vector. You will learn it later. So propagation is in negative x direction, electric field is in y direction. How you can calculate? Electric field is, this is the vector. So E is given as, how this is given? This is given as AY. So electric field is in y direction. Propagation, the format is omega t minus beta x, means that is positive direction. So here positive means it is in traveling in negative direction, and here x is given, so it is negative x. If I write here beta y, I will write wave is propagating in negative y direction. Okay. Then next thing, so this was a problem. Now we are going to calculate beta. What is the equation for beta? Beta, I told you, omega by v. Here the medium is not specified, so you assume that it is free space. So in free space, velocity is c, that is 3 into 10 raised to 8 meter per second. So beta is equal to omega by c, and this is, what is this format? The format is E is E naught cos omega t plus beta x. Okay, so from here omega value is 10 raised to 8 and c value is given. So according to the c value, you can write 10 raised to 8 here, divide by 3 into 10 raised to 8. You will get beta as 1 by 3. So omega by v, here as it is free space, v, you substitute v as c. C is 3 into 10 raised to 8 meter per second. So you got beta, and the unit is radians per meter. Next, you have to calculate time it takes to travel a distance of lambda by 2. Here you have to learn one thing. The distance lambda corresponds to t. Okay, so lambda by 2 distance, the time taken will be t by 2. Okay, so to travel a distance of lambda by 2, the time taken will be t by 2. Again you have to calculate t, but what you have only 10 raised to 8, that is omega. So omega, what is omega? You have some basic equations, that is, what you know is omega is equal to 2 pi f, or that is equal to 2 pi by t, because t is 1 by f. So t will be 2 pi by omega. Okay, so calculate 2 pi by omega to get t, and time taken to travel lambda by 2 will be t by 2. So you will get t by 2, that is equal to 1 by 2 into 2 pi by omega, that is equal to pi by 10 raised. So again you have to write in terms of seconds. Here it is 10 raised to minus 9, so you write it as nanoseconds. So this is how you can do the problem. So you have to learn the basic equations, and also when electric field or magnetic field is given like this, the unit vector of the field will be directly given, and direction of propagation can be calculated like this. If this is beta z, it is propagating in z direction. If it is beta y, it is propagating in y direction. If it is beta x, it is propagating in x direction. Then check the sign. If it is negative, it is traveling in positive direction, and if it is positive, it is traveling in negative direction. So according to this, we can say that wave is traveling in negative x direction and electric field is in y direction. Hope it is clear. Now coming to another portion, that is Phasor form. So we are trying to consider a vector, say A, x, y, z and t. So these three are the position coordinates, and then t. And Phasor form means we are taking only the space coordinates together. So Phasor form means as, x, y, z. So A, the dependency of x, y, z is given with this as. And time dependency we give separately, and as this is a time harmonic field, you can modify this as as. A can be written as as means it consists of x, y, z functions, and rest what is remaining is the t function. That as it is time harmonic, you can give it like e raised to j omega t. So you write vector A as real part of as into e raised to j omega t. If you write like this, the thing is, when you take the derivative with respect to t, what happens? As is independent of time because it just consists of functions of x, y, z. So as can be written like that. You just have to take the derivative of e raised to j omega t. E raised to at is a e raised to at. So here you can write it as j omega into e raised to j omega t. So from this you can learn like this. What is the use of Phasor form? Dou A by dou T can be written as j omega as. Okay. Similarly, integral of A can be written as A by j omega. Because integral of e raised to at is integral of e raised to at will be e raised to at by A. Similarly, d by dt of e raised to at will be a into e raised to at. So this is function itself. This is functioning itself. So what you should know, integral means dividing by a and derivative means multiplying by a. That happens here. Here you multiply by j omega. Here you divide by j omega. Okay. So you have to learn these two things when you deal with Phasor forms. So coming to our Maxwell's equation, these were the Maxwell's equation which you knew. These things you know. Del dot D is equal to rho V, del dot B is equal to 0, curl E is minus dou B by dou T, and curl H is J plus dou D by dou T. Here you take del dot, when you assume a charge free region, you can write del dot D is equal to 0. So del dot E will also be equal to 0. So Phasor form you write D or E you write as ds. So that means D, the corresponding Phasor form will be ds. Similarly E vector, the Phasor form will be vector es. So you can write like this, and D is epsilon E. Okay, so del dot D 0 means del dot E will also be equal to 0 as charge is equal to 0. So based on that you write del dot Es is equal to 0. Second again B is mu H. Based on that del dot Hs will also be equal to 0. So these two are straightforward. Then you take this. Here you are taking derivative with respect to t and you are assuming a time factor e raised to j omega t. When you take the derivative, it is equivalent to multiplying with the j omega. Okay, so you write curl E is equal to minus j omega and B is given by mu H. B is equal to mu H. So you can write it as mu Hs. Okay, so minus j omega into mu Hs. You can write like this. So the derivative component is replaced with the function minus j omega. This is the use. Okay. Minus dou by dou t is replaced by minus j omega. So curl Es is minus j omega mu Hs. Next curl H is equal to, again you write j is sigma E. That is another equation which you should know. Vector j is equal to sigma E. Based on that you write j, instead of js you write sigma es plus again dou by dou t you replace with j omega and again d is equal to epsilon E. So you write sigma es plus j omega epsilon es. So these are the four equations, time harmonic Maxwell's equations. First two equations are same. Here and here dou by dou t is replaced by j omega, and in Phasor form it is replaced like this Es, which shows that it is a function of only the space variables like x, y, z, and it is independent of time. Okay. Now you have the third equation. Take this equation, curl Es is equal to minus j omega mu Hs. This is your third Maxwell's equation. Okay. And taking curl on both sides you get, you know that curl Es is minus j omega mu Hs. Curl Es is equal to minus j omega mu Hs. This was your third Maxwell's equation. So taking curl, you get del cross E is equal to minus j omega mu. This much is a not vector. So take the scalar quantity outside, minus j omega mu into curl Hs. You are taking the curl. And this is a vector identity, curl A, del cross A is del of del dot A minus del square A. Earlier also we saw this. So based on that you can get del dot Es. Okay, del of del dot Es minus del square Es is equal to this thing. Minus j omega mu into, you substitute for curl Hs. Curl Hs, that is fourth Maxwell's equation, which is sigma plus j omega epsilon into Es. On substituting the whole thing, you get del square Es minus gamma square Es is equal to 0, where gamma is equal to j omega mu into sigma plus j omega epsilon. Here you take this part as gamma square. Okay, from this how you can write gamma square is equal to j omega mu into sigma plus j omega epsilon. This is a very important equation. So gamma will be equal to square root of j omega mu into sigma plus j omega epsilon. So this is a very important equation. Okay, sigma is square root of j omega mu into sigma plus j omega epsilon. Now coming to this, similarly in similar derivation you can calculate for H also. Del square Hs minus gamma square Hs equal to 0, where gamma square is j omega mu into sigma plus j omega epsilon. Gamma is square root of, don't forget that square root. Gamma is, propagation constant gamma is square root of j omega mu into sigma plus j omega epsilon. Okay. This is called propagation constant. Gamma is called propagation constant. So these two equations, this del square Es minus gamma square Es equals 0 and del square Hs minus gamma square Hs equals 0. These two equations are called vector wave equations or Helmholtz wave equation. Both cases, gamma is the propagation constant. Gamma is given by square root of j omega mu into sigma plus j omega epsilon. So we understand that propagation constant is gamma is equal to alpha plus j beta. This is propagation constant, and alpha is attenuation constant and beta is phase constant. Now you know that gamma square is equal to j omega mu into sigma plus j omega epsilon. So equating these two, on alpha square you get alpha square minus beta square plus 2 alpha beta j. Okay, this is gamma square and this is equal to this. Okay, so on expanding this, it will be j omega mu sigma minus j square is minus 1 minus omega square mu epsilon. So this is the real part, this is the imaginary part. Okay, so this is equal to this. So you get alpha square minus beta square, that is equal to minus omega square mu epsilon, and real part, imaginary part, that is alpha b2 alpha beta is equal to omega mu sigma. Okay, so on solving these two, you get, no need to write all the whole solution, and the solution you should learn, that is equal to alpha is equal to omega square of mu epsilon by 2 into square root of 1 plus sigma by omega epsilon the whole square minus 1. So this is the equation for alpha. Okay, and for beta omega square root of mu epsilon by 2 into square root of 1 plus sigma by omega epsilon the whole square plus 1. So these are the equation for alpha and beta. So alpha, it is attenuation constant, beta, that is phase constant. Alpha plus j beta, that is equal to gamma, which is propagation constant. So again the terms, gamma is propagation constant, alpha is attenuation constant, and beta is phase constant. The value of gamma is square root of j omega mu into sigma plus j omega epsilon. On solving, you get the values for alpha and beta. Alpha attenuation constant and beta phase constant. That is equal to omega square root of mu epsilon by 2 into square root of 1 plus sigma by omega epsilon the whole square minus or plus 1. Minus 1 in case of alpha, plus 1 in case of beta. And you know that velocity u, that is equal to omega by beta. Okay, it's omega by beta, and this will be equal to 1 by square root of mu epsilon.